Hi guys, welcome to the next lecture. So today we will be talking about something called sets. What are they? What do they represent? So let's talk about it. While working on real numbers in the previous videos, while learning about real numbers, we used some symbols. What were they? The symbol representing real number, the symbol representing natural numbers, the symbol representing whole numbers, a symbol that was representing the set of integers, a symbol that was representing the set of rational numbers, the set of rational numbers. So I definitely did use this word set there. So what do we mean by set? This symbol, which is representing set of real numbers, is essentially a collection of all real numbers. So essentially, if I write R, this symbol R, that means that I am talking about all real numbers. Or if I am talking about some particular real numbers, for example, say n, then I am talking about just natural numbers. So n represents collection of all natural numbers, and so on and so forth for W for whole numbers, Z for integers, and so on and so forth. Okay. So all these symbols are representing collection of some sort of numbers, right? So collection of some sort of objects, collection of distinct and well-defined objects that are related to each other in some sense or the other. Maybe it's characteristic. For example, when I say R, it's collection of real numbers. So you will find all real numbers out there. Okay. Natural numbers, set of all natural numbers. So you will just find natural numbers and they are related to each other. So well-defined objects is actually a set. That's what is a set. That's how you define a set. So for example, let me give you a simpler example. When I say related to each other, well-defined, distinct objects, what do I mean by that? If I say I want to represent all the vowels, let A be that collection of all vowels. Now, collection means that I'm collecting these vowels in some place, and that place will be called set. It is represented with curly brackets. So when I write these curly brackets, this means this is a set. And what I will be writing inside, they are elements. Now, what are the elements of this set A? I can say A is equal to, I know what are the vowels. The vowels are A, E, I, O, U. A, E, I, O, U. So these are the vowels that we have. And each of these are elements of the set A. They're elements of the set A. I've just written A here. E is also an element. So all these are called elements. And how we denote it? So in this video, I will be talking, about notations also here and there. So how I write it down as A belongs to capital A out here. Whenever you are writing a set, whenever you are denoting a set, so you always use capital letters. And you always use lower cases for elements. Here, in case the elements are not number, then you always use lower cases. So this notation that you see here, this notation means belongs to. It's an important notation when it comes to set because that's how you denote elements. An element belongs to a set. Clearly, B, I cannot see, B is not a vowel, I cannot see it in this set. So B does not belong to this set A. This is does not belong, okay? So that's how you denote a set. A set is a collection of some distinct entries, but they're related to each other by some characteristic or so, and they're well-defined in nature. Now, what do I mean by well-defined? I'll give you some more examples out here. So let us take an example of, say, I'm calling E, capital E, the set of all even numbers less than or equal to 20. So set of all even numbers less than or equal to 20. If I ask you to tell me what is the set of all even numbers less than or equal to even natural number. So let me just write it down here. Even natural numbers, set of all natural numbers, even natural numbers less than or equal to 20. So there are two ways I can write it down as. I can say that I can denote these numbers as, say, x belongs to n, where x is an even number. So this slash that you can see here, I can write it down subject to or such that x is a natural number. So what have I just done here? I have defined the set. I've just not written the elements. I've defined the set according to the property it carries. The property it carries, it's an even natural number. X is a natural number. It's an even a natural number less than or equal to 20. So that's the property that it is carrying. So it's an even natural number less than or equal to 20. Now, whether it's me, whether it's you, if we know about numbers, you and I both will write it down as the elements as, we will write down the elements as 2, 4, 6, 8, so on and so forth, only the even numbers, including 20, because it's less than or equal to 20. Similarly, if I give you an example of odd. So odd natural numbers less than or equal to 20. So set of O is the set of all odd natural numbers. So it is equal to, say, x belongs to n, because it's a natural number, such that or subject to x is an odd. I can write down number also here because I've already written natural here. So x has to be natural. Odd number less than or equal to 20. Now, whether it's you or it's me and we know about numbers, we would know what are the elements of this set, and we can denote it as an set of elements also here. So we can write down, it's going to be 1, 3, 5, so on and so forth till 19, because 20 is even, so 19 is odd, and we can just write it down like this. So there can be two ways in which, you can write down a set. There can be a way where you're defining set with its property, which is this and this. We're defining set with its property. And there can be a notation like this, where you are actually mentioning the elements of the set, and this is called the roster way of writing it. This is the roster notation of a set. Now, the example that I gave you of the set of even natural numbers and odd natural numbers, they're the same for you. These two sets are same for you and me. It will not change. The definition of these two sets will not change whatsoever. Whosoever you will ask and they know about numbers, they would know what is, in these two sets. And that is why these sets are well defined. And when you are creating a set, you would want a well-defined set. You do not want a random set, which means something else for you, something else for me. Some sets could be not well defined. Now, We wouldn't even include them in the definition of sets. Now, what kind of sets am I talking about? Set of favorite teachers. You might have different set of favorite teachers. I might have different set of favorite teachers. Set of beautiful teachers. Beauty lies in the eyes of the beholder. So, you might find someone beautiful. I might find someone else beautiful. So, we cannot define, these sets at all. Favorite travel destination of your maths teacher. You might think there's some other places, someone else might think there's some other places. So these are not well defined in nature. So we will not include them in the definition of sets. What is a set? That means a set is a collection of distinct and well-defined elements as such. They would be related to each other in some way or the other. So if you actually try to visualize it, what is a set like? It's like a box. It's like a box which you keep on filling with things. So suppose you have a box, okay? And you put certain things on it. If I want to make it a set of, say, phones, so what I'm going to do, I'm going to collect all the phones in the home, whatever phones I have, whosoever is living in my house, and all the phones, and I can keep all the phones here. So this becomes a set of phones. If suppose this is a set of all the blocks that my daughter has, so I can put blocks here, and this becomes a set of blocks. Now I'm going to come to something very interesting here. So suppose you have an empty box. It's a possibility that I have an empty box or an empty tray where I was collecting everything. Now I have taken everything out. I've taken everything out. Now it's an empty tray. It's an empty tray. And I have a special name for this set. It's like an empty set. In maths, we call this empty set, which doesn't contain any element, phi. We call it phi. It's like an O with a cut. It's called phi. Phi is a set of no elements. It contains no elements at all whatsoever. So but what is interesting about elements and numbers and number of elements of a set? What if I do something? I have a tray and I keep an empty jar on it. It's an empty jar. But my tray is no longer empty. My tray consists of an empty jar. So my tray consists of my tray is a set. My tray is a set which contains another set, or which contains another set which is called phi. So this situation will look like a set which contains phi. So let's try to understand this again. So if you have an empty tray or empty box or empty tray, this itself is phi. It has no elements. Now, if you have a tray which consists of an empty jar, now this tray behaves like a set which contains phi. It's a set which contains phi. Earlier, because this was empty, so it was the set phi. This time it is a set which contains phi. Now what happens? I am putting, this is my tray, and I am putting, so now this is a tray with one empty jar, and I'm putting another tray, another small tray inside it with another empty jar. If that happens, then what do I have? I have a set which contains phi, that's an empty jar, and which contains another set, that's your tray, which contains another empty jar. So what has just happened here is that now compare it with numbers. Think in terms of numbers. So this was an empty tray, was phi. It contains 0 elements. 0 elements. Now you have a tray with an empty jar in it. But as a set, if I'm looking at this tray now, I have 1 element. So this set contains 1 element. Now you have a tray with an empty jar and another tray inside it with another empty jar. So this becomes 1 element, 2 elements. So in total, I have 2 elements here. In total, I have 2 elements here. Similarly, I can look at a situation where you have phi, you have set which contains phi, and you have a set which contains phi and set of phi. If you collect all these, you have 3 elements now in this new set. This is your 1 element, 2 element, 3 elements. In total, you have 3 elements on the tray. So that's how numbers are related to sets. And that's how you can also think of sets. You can classify sets in terms of finite sets, infinite sets, singleton, and the null set. What is the null set? We have just spoken about it. So that's a set that contains no elements and we call it phi. The set that contains no element and we call it phi. Now, singleton set. A singleton set will be which contains just 1 element. So when I say set that contains phi, it has 1 element exactly. So that becomes a singleton set. It contains just 1 element. You can think of other numbers, other way also, to put this. So you have just 0, the set that contains just 0. It could be probably set which contains just 1, and so on and so forth. Now I'm going to first talk about finite sets. So finite sets are sets where you can, you have finitely many numbers that you can count here. So for example, this set that we had, phi, singleton phi, then a set that contains phi and singleton phi. So in total, you had 3 elements out here. So therefore, it's finite. I am able to count, and that too in a finite manner. I'm able to stop somewhere finite. So that is a finite set. 1, 2, 3, 4 till 10. The sets that we represented, the set of even natural numbers less than or equal to 20, the set of odd natural numbers less than or equal to 20, and so on. But when I say the set of all natural numbers, that is n, do you think that can be finite? No, that's infinite. Infinite means there's no stopping to it. You start writing the numbers starting with 1, 2, 3, but you don't know where to stop. It keeps on going on and on and on and on and on. Every next number is 1 unit apart from the previous, and it goes on and on and on and on and on. That's what is infinite set. So what we've just done is we have classified sets in terms of finite, infinite, singleton, and null sets. Next lecture will be on operations on sets that we can apply and what are the major properties around these operations. Thank you.